Okay, so conservative forces. Conservative force. If a force is conservative, if a force is conservative, then this curl F is equal to 0. I will explain what is curl F. That is this del operator cross F is equal to 0. Okay. Now I will explain what del operator is. Del operator is this del x partial derivative I cap plus del y times j cap plus del z times k cap. So this is the del operator. Okay. Say example of del operator, say say potential energy. If u is potential energy, if u is potential energy, then force is equal to minus del u. Sometimes the vector sign is not given also. This vector sign on the del operator is not, it is implied that it's an operator. This del is not a vector, it's an operator. So u is potential energy. That means we know that fx equal to minus del u del x, and fy is equal to minus del u del y, and fz is equal to minus del u del z. And we know very well that this force, if we express like this, minus del u del x I cap minus del u del y j cap minus del u del z times k cap. So we write it like this in short form with this del operator. So that is minus del u. Okay, so this is minus del u, f equal to minus del u. Now curl f. Now we will learn about curl f now. So curl f is equal to del operator cross f. Del operator cross f. Let's see what we get by this del operator cross f. So curl f is del operator cross f means we can write by determinant I j k, then del x, del y, del z, and fx, fy, and fz. That means if you expand these terms, we get I times del fz del y minus del fy del z minus j cap times del fz del x minus del fx del z plus k cap times del sorry k cap times del fz del x minus del fx del y. So this is curl f. Okay. Now let's consider force. Consider a two-dimensional force that is along or in the xy plane. That is in the xy plane. That means we can, for the time being, we will not consider the z axis. The force has no component along the z axis. So let the force be, let the force be F is equal to Fx I cap plus Fy j cap. Fx I cap plus Fy j cap. Y axis, and then this is the x axis. Now consider the point xy and we consider a rectangle. We consider a rectangle, a small rectangle like this. So this is a point xy. They are the midpoint of the square, and let the it's not a square, it's this thing, rectangle, a small rectangle. Now let the sides be like this. Consider this. Now say this is delta x each. On each side it is delta x, and this each side it is delta y. So it is like this. Delta y, delta y, and there delta x and delta x. So this rectangle, has sides 2 delta x and 2 delta y. Now we know in a conservative force, so or rather in a conservative force field, work done by the conservative force, forces in a closed loop is equal to 0. Work done in a closed loop equal to 0. So whatever closed loop it may. So in a closed loop, the work done by the conservative force is equal to 0. That means W or summation or integration, closed integral of dw over a path delta W, the closed integration over a path. That means if you start from this point and move on like this and end up at the same starting point, the work done is 0. So this small rectangle is also no exception to that. Here also the work done in the closed path is 0. Now this delta x and delta y are very, very small and they tend to 0. Now I'll just, these are the points, these dots. Okay. Now let's name the points. 1 says 1, this is 2, this is 3, and this is 4. Now at point 1, what is the y component of the force? See, at xy the force is at x comma y, the force is fx I cap plus fy times j cap. So at point 1, what is the y component of the force? So the y component of the force is this way, upward, obviously along the y axis. At point 1, okay, at point 1, y component of the force is fy minus del fy del x times delta x. This is C. That means here to here. See, along this line shown, only x varies, right? So from this center point, the center of this rectangle to the point 1, this line is parallel to the x-axis. So fy varies with the x coordinate. So that is why del fy del x is the rate of variation of fy with respect to x, and that is multiplied by delta x. And same way at 3, this force is fy, I mean the y component of the force, plus del fy, again del x multiplied by del x. That is it na? The rate of change with respect to x multiplied by the change in x. See, from here to here, from the center point of the rectangle to this point 3, the rate of change of fy with x is del fy del x and multiplied by del x, delta x. This means this length is delta x. Okay, so we are concerned with the y component here, and let's see. Now we will be concerned about the x component. At 4, the x component. At 4, the x component is f fx plus del fx del y times del y, because we know that we from this point, again you see from xy to this point 4, variation is along y, x coordinate is constant, right? This line is parallel to y axis, so fx varies in this way, del fx del y multiplied by del y, so this gap is del y. Similarly at point 2, the x component of the force is fx, I should write plus del fx del y multiplied by minus del y, or rather insert this minus sign before, minus minus del fx by del y multiplied by del y. Okay, now we are going to calculate the thing. So along this rectangle, the line integral of this force is 0. That means the work done, this work done in the closed path along this rectangle is equal to 0 because the force is conservative. So let's name the points A, B, C, and D. Okay. So now, therefore, work done along AB plus BC plus CD plus DA is equal to 0. Now work done in path AB, see along AB the force may vary, but as this is very small length, we will consider the force at point 2. In average force along, this is very small, delta x is very small. So here fx minus del fx del y into delta y multiplied by twice delta x plus work done along BC fy plus del fy del x along delta x multiplied by 2 delta y. Now work done along CD, here minus sign because the displacement and the force are opposite in direction. Here fx plus del fx by del y times delta y times 2 delta x, and the last term wdA, that's also minus sign, fy minus del fy del x times delta x multiplied by 2 delta y, and this sum is equal to 0. Therefore, after simplifying, what do you get? There you see minus see fx this so fx, this thing will cancel out actually, no? This thing will cancel out. See, this fx times 2 delta x and minus fx times 2 delta x and fy times 2 delta y, and again fy times 2 delta y, this will cancel out. So we will be left out with minus del fx by del y into twice delta x delta y plus del fy by del x, again twice delta x delta y, again minus del fx by del y times twice delta x delta y, again plus del fy by del x twice delta x delta y is equal to 0. So therefore we get that. So this all will cancel. This thing, that 2 delta x delta y, this will get cancelled. So we get del fy del x is equal to del fx del y. We get this one term. Now we have taken this rectangle. This rectangle was along which plane? So this rectangle is in the xy plane. Similarly, if we take a rectangle in the yz plane and the rectangle in also the zx plane, we will get the following result. For the rectangle in the yz plane and zx plane, for the yz plane you will get del fy del z minus or like this only, minus del fz del y is equal to 0, and for the zx plane you get del fz del x minus del fx del z equal to 0. So we get all this three. So this three combined, you get this curl f is equal to 0. All these three terms combined. So from here you got this term del fy del x minus del fx del y is equal to 0. So therefore all the three things combined, so this and this, all the three combined, you get in only one equation, that is this curl f is equal to 0. So for a conservative force, you know, this curl f is equal to 0. So this is curl f or this del operator cross f this, and for conservative forces curl f is equal to 0. Now suppose you are given a force, for example you are given a force like this y I cap plus xj cap. So by looking at the force, you know it is conservative because fx equal to y and fy equal to x. So therefore del fx del y. Here we need only because there is no z component. So I think there fz, no, that's not fz there. One error was there. Del fy, this was fy, del fy, yes, here also this is del fy. Okay, by the way, so we need this only, this term only this term, right? Because the force does not have any z component here in this problem. So del fx del y equal to how much? 1, and del fy del x is also equal to 1. And suppose you have been asked to find out, find work done, find work done by the above force, in the path, say suppose a parabolic path, say y square equal to x, something like that, y square equal to x from 0 0 to 1 comma 1. So that is this is the x and y axis. That means you know y square equal to x, how is this curve? Like this, huh? Y square equal to x from 0 0 to 1 comma 1. That's also a valid point here on this parabola. So you need to do nothing actually, because you know it is a conservative force. So you'll choose your own path, your own convenient path to calculate work done, because the work will not depend on path. So I choose this path plus this path. Somehow, see, any way you reach from 0 0 to 1 1, that is valid. 0 0 to 1 1, whether you reach by this parabola or by this breaking up into these two parts or directly by a straight line, it will not matter. So here we divide into path 1 and path 2. Now, so the required work done is equal to work done in path 1 plus work done in path 2. So for path 1, only fx will matter. So what is fx along path 1? If fx equal to y, so 0 times dx. So that will be 0 plus, so fy is equal to x. So here, so this is x equal to 1, right? And this path 1 has equation y equal to 0. Path 1 has equation y equal to 0. Path 2 has equation x equal to 1. So it is integral fy, that is 1 times dy from 0 to 1. So anyway, it's 1 joule. So therefore the work done is equal to 1 joule. Similarly, if any expression for work done is given and you have been asked to calculate work done by a certain path, if the equation is also given, if luckily the force comes out to be conservative, if you substitute here and see, or this curl f is equal to 0, then you can choose your own path. The best and simplest of all paths is to break up into x, a path parallel to x and a path parallel to y.